So, going through the homework. This 5-1, 5-2, 5-3, 5-4 worksheet. This worksheet packet will cover the majority of your quiz on Wednesday. We are going to do something new today with 5-5, but this worksheet packet that you're turning in will be the majority of the quiz. Guys, please put your phones away. So, questions over this. 5-1, easy? I mean, the hardest ones to me are the domain and range. Number one, I would say the domain in that case should just be what? 0, 1, 2, 3, 4, like that. Because you're only going to pay for 0 weeks, 1 week, 2 week, 3 week. They're not going to give you a tenth of a week. And then the range should be $0. 1 week would be 175, 275, and so on and so on, right? Easy? For number one, what kind of graph technically should you probably draw? Discrete or continuous? Discrete. Number two, though, you're putting water in a pool or actually taking it out. Is that more of a discrete or a continuous graph?
I got like a weird line
for number two?
Yeah.
Well, what points do you plot? Well, the points I would plot for this one would probably be 0, 10, 20, 30, 40.
I got like 58.2.
Okay, so yeah, you'd be 60. This would be what, 58.2? And then you plug in a 20, it'd be 30. What is it?
56.
Yep, okay. And 30 would be 3 times 18, 54.
I got, maybe I just messed up one.
Huh? Well, and again, going back to the discussion about, we're going to have lots of different ways to draw these lines, right? What is the benefit of plotting more points? You notice where you mess up. If you have 4 points, if your graph looks like this, I mean, it's pretty easy to see where you messed up, right? And maybe you plotted the point wrong. Maybe you did the math wrong, right? Well, if you see everything lines up except for 1 point, yeah, I made a little goof. Well, we all make little goofs once in a while. So the more points you plot, a lot of times the easier it is to find those mistakes. Anything on the first page? Okay, how about 5-2? XY intercepts? Is this like super easy now or questions? The biggest questions to me that I want to make sure you understand is 5B. What do the intercepts represent? Huh? Well, that's the slope. That's not the x and y intercepts. Your graph should look something like this. Yes? The question isn't what's the line represent. The question is what does that point represent? And what does this point represent? But what does this one point represent? It's 0.50, right? What does that mean? How many weeks have gone by? 0, which means that's the start. That's the starting point, right? We're starting with $50. That's what it represents. What does this point down here represent? Where it's, what was the coordinate of that point? That'd be 0, 5 or 5, 0. What does that point represent? What ends? In this, well, the weeks aren't ending, but we're out of money. The money ran out. The money ended. Right? Basically. When you are doing X and Y intercepts, that's one of the nice things about doing X and Y intercepts is typically in a story problem type situation, it's basically a starting point and an ending point. We have a starting point where we're starting with $50, and that was one point. That's the y-intercept. The x-intercept is our ending point of that's when we're going to run out of money. Yes? Anything else on this worksheet? How about 5.3? Rate of change. Easy stuff or questions? Cam? Easy stuff? Anybody else? Questions? How about 5.4? Slope? Slope formula? Anything at all on this? On Wednesday, everybody's taking a quiz. This is going to be 80% of your quiz, right here. If there's 10 questions on the quiz, 8 of them will come from these 4 sections right here. Is there anything you guys would like me to cover? What's that? On what page? 5.4, number 1. The blank is the difference between the y values of the 2 points. Is it rise or run? Which one does the y's? That's the rise. So the first one's rise, the second one's run. That's all that is. Rise over run, right? Easy? A lot of people get confused on, oh, sorry, that was 5.3. You said 5.4, right? Oh, sorry. So a lot of people get confused on this one, just with the weird boxes. How would you find the slope using these 2 points? How would you find the slope?
2 and 1 over.
So they tell you it's, so it'd be 2 minus 1, right? Over, they tell us it's 2 over 1. So if it's 2 over 1, what has to be in the bottom? 9 minus 3. So those go in the little boxes. And then 2 minus 1 is 1. 9 minus 3 is 6. So a lot of people get confused over just because this is the question, right? Like they told us it had to be 2 minus 1, because it could have been 1 minus 2, right? And if it was 1 minus 2, we just have to put 3 minus 6. Are we good with those? Anything at all on these? How about the last ones with the x-intercepts to find the slope? X-y-intercepts. Easy stuff? All right. Pass those up. All right. Guys, please keep your heads up and pay attention with this. New stuff. And I'm hoping this stuff, with some prior knowledge that you guys already have, is even easier than it sounds. Generally speaking, when you do any kind of math, do we just jump into the deep end, or do we slowly build our way to that deep end? Right? Like we introduce things in different parts, and they kind of build up to something. you kind of have already seen one of the last things we're going to do in this chapter, right? This whole chapter is kind of some review. What I mean is, do you guys already know slope-intercept form? Y equals mx plus b. You guys have already seen that. You've already used that, right? That's one of the last things we're going to do in this chapter, okay? Because you've seen that, again, this chapter isn't, to me, about being good at this stuff. It's finally about mastery. We have to be good at this stuff. Direct variation is simply equations that can be written in this form. Okay? Equations that can be written simply in this form. For example, y equals 3x, y equals negative 2x, y equals 1/3 x. Those are all examples of direct variation. Basically, what is the only thing you're doing to the x number in order to get the y number? Like if you were going to plot points, what's the only thing you can do? Times. Like if I was plotting points, if I plug in a 1, what are you going to get out for an answer? 3. If I plug in a 2, you're going to get a 6. If I plug in a 7, you're going to get a 21. Like the only thing you're doing is timesing by 3, right? With direct variation, that's exactly what it is. It's just multiplication to get from one variable to the other. Now, because of that, they have some interesting characteristics. I want you to also think y equals mx plus b, something you've seen before. What's missing? Huh? The b. The b's missing. Which means if you were going to graph that, if you're going to graph y equals 3x, what's the b? What's the y-intercept? What is my y-intercept? How do you find the y-intercept? Make the x a 0. So that becomes a 0, which means 3 times 0 is 0, which means y equals 0. This graph is going to look something like this.
So it's going to be 0 every time.
It's going to be 0 every single time. With direct variation, if you have, like the 3 examples I just put on the board, 3x. What was the other one? 2x, or negative 2x, and 1/4 x, something like that, right? All 3 of these are lines. They all have different slopes, but they all will have one thing in common. They will go through 0, 0. All 3 of them will go through 0. Direct variation, it has to go through y equals 0, 0. Or y equals 0 or the point 0, 0. This one would look something like this. This would look something like that. This would look something like this. But all direct variation equations go through 0, 0. It's an easy way to recognize them. Okay? It's also because we can recognize it, we can use it, and also because it's a fact, we can use it once in a while. Okay? Now, direct variation also, because it's just multiplication, if things vary directly, well, let's do this. Everybody take a look at page 329. $329. If you look at a question like number 7, it says, the value of y varies directly okay? And it says y is negative 3, when x is 1. Find y when x is 12, right? Now, when things vary directly, there's two ways we can do this. We could use the idea that because it's directly, that means there has to be an equation in this form that gives us these. Which means there has to be a point where when I plug in a 1, the answer is -3. Which means, what's the equation have to be? What's the only way you can multiply a 1 by and turn it into a -3? What's this number have to be? Y equals -3x. Does that make sense? So, it wants us to find y when the x is 12. What's the answer? What's 3 times -12? Or 12 times -3? What's 3 times 12? 36. So the answer is -36. That's one way. Yes. Okay. One method, when you see it says it varies directly, is you can use that idea that it has to be y equals kx, which means all we have to do is find that equation. Okay? What do you think another method of doing this is? Totally different method. What does this problem kind of sound like that we could set up? Another method we could do this is just set up a proportion. -3 goes with what? 1. Now, the 12, where would I put the 12? If I put the -3 on top and the 1 on the bottom, where does the 12 have to go? Top or bottom? Why? Because, yeah, we put the x on the bottom, which means the 12 has to go on the bottom. So, now how do you solve this? Butterfly. So, y equals -36. Just butterfly it, right? Either method here will absolutely get you to the right answer. So, look at number 8. Same idea. Says it varies directly. It says when y is 6, when x is 18. Well, y is 6 when x is 18. What does the equation have to be? What's the only number that you can multiply well, careful. What's the only number you can multiply an 18 by and turn it into a 6? A 3's in there. But do we want to times by 3 or divide by 3? We want to divide by 3. So the k has to be 1/3. This works, right? So my equation is 1/3 x. Y equals 1/3 x. So what does it want us to find? Find y when x is what? 12? Great. Plug in a 12. What's the answer? What's 12 divided by 3? 4. The answer is 4. That's one method. The other method is just to set up a proportion. 18 is to 6 as, and if I put the 18 on top, where does the 12 have to go? On top. So, how would I solve that? I would do 12 times 6, which is 72, equals 18x. What's 72 divided by 18? 4. Doesn't matter which way you do those, either way you get 4. there's two ways to think about these direct variations. One is, yes, everything has to be proportional. The other method is, I kind of like thinking of these as y equals mx plus b problems, but the b value is always 0. Does that make sense? We are going to get to y equals mx plus b. We are going to use y equals mx plus b. We're kind of starting with these. These are special cases where the b is always 0. Okay? So I want you to look at 329. Let's look at 2, 3, and 4. You tell me, yes or no, are those direct variation? Basically, can you make them look like this? Can you make them look like just y equals 3x, negative 2x, 1/3 x? Number 2, is that direct variation? No, that's got a b value, doesn't it? How about number 3? Yeah, the only thing you'd have to do is divide by 2, right? So yes, number 3 is yes. How about number 4? What if you just move the x over? That one says x plus y equals 0, doesn't it? Can you make this solve for y? What would it equal? If you move the x over to the other side, what would it be? What's 0 minus x? Be negative x. What's the k value in this case? What's that multiplier? What number is out in front here? Negative 1. That's what we call the constant of variation. So whenever it asks for constant of variation, it's asking for the k value. Like, what is that number you multiply by? Okay? Easy? So, like in number 3, we said that was a direct variation, right? What's the k value? What is that constant of variation? If you got the y by itself, what would the k be? It says 2y equals negative 8x, right? Then what's y equal? Negative 4x. So that's the equation, which means the constant of variation, or the k value, would be that negative 4. That's the constant of variation. Okay? Easy? If you look at number 5, how could we tell if that's a constant of variation? Or how can we tell if that's direct variation? It has to be the same ratio. If you, like, look at the 2 to 4. Like in number 5, see that 2, 4? What would you multiply a 2 by and turn it into a 4? Times it by 2. Well, that means it has to be constant. You have to be able to multiply by 2. Is that true for a 5, 7? If I times this by 2, do I get this? Then this is not going to be direct variation. If you look at number 6, what would you multiply a 3 by to turn into a negative 6? Negative 2? Can you do that for all 3 points? Can you do that for the next one? Negative 1 times negative 2. Negative 4 times negative 2. Does that work for all 3 of those points? Yes, so that one is direct variation. And the constant of variation in that case would be negative 2, because that's what you're multiplying by. Good? I don't think this stuff is overly difficult. I think we got this. Yes?